It's 2 minutes past. Probably we should get a start. Della?
Yeah, let's go into start.
Okay.
We have 28. We have at least half of the people.
Yeah.
So let's start.
Okay. So let's start now. Welcome everyone. Thanks for participating in this online session from the Research Metadata Schema Working Group. This is a part of the RDA Virtual Plenary Program. Before we get on the agenda, I have a few logistics items to note. First, probably you notice I clicked the recording button. So if you object to recording, please let me know. You can raise your hand. If not, we can go ahead. I don't see my chat. Okay, it's here. And slides. Sorry, I have difficulty to move along the slides. It does not move for me. Okay, secondly, we have a collaborative notes. The link is on the screen and in the chat. We will use these notes extensively during the session. Please put your name in the table, participants table, and put any comments and thoughts into the notes. Also, during the session, I will put everyone on mute except the speakers. If you have any questions specific to speakers, please put them in chat. Okay, I would like to thank those people who contribute to planning of this session or as a speaker of this session. And then here is the agenda for today. Not many people new to this working group, so we will start with the introduction. Then we will have 3 user cases that line up with schema.org. We have a reporting of progress made so far, and we will spend a lot of time on discussion. Okay, so I will give an introduction of context, objective, and how we operate during of this working group. So here's a bit of context. So in last decades or so, we have seen increased number of data repository or catalogs appear. That's probably due largely to the call for research reproducibility, data sharing, and the fair data principles. So we may see more repository like this to come. And this is a good thing. We have a data registered, available to researchers, but there is increasing challenge for researchers to find the data with so many repositories there, and researchers may not even know the existing of some repositories, especially if a research went to doing a cross-discipline research. The data set may need gathered from different repositories. So we have those data made available. However, there is data discovery islands. So in reality, how user or researcher search for data. So so our data shown. So we sorry, I haven't introduced myself. I'm Ming Fang Wu, working for Australia Research Data Commons. We have a national research data catalog. So our search log shows 80% of our data, 80% of entry are from the Google web search. So in reality, researchers are using web search tools to search for data. And what web search tools does is treat the metadata landing page, whatever information there, as a bag of words. And they just index them, do some statistics with them, and rank them. However, the metadata and their landing page that inherently are structured data by themselves. This structure encode semantic meanings. If we use those semantics properly, I believe we can do a better job to make data more discoverable or have a better data discovery experience for users. And this issue is not only to research data, and there are many structured data on the web. For example, there are news, movies, books, finance, and many more structured data on the web. So how to make those structured data more understandable by machines, and then make them do a good job for human being. So for those people who on the call who followed the semantic web, so you may see there are many discussions on sophisticated semantic web standards. After many years of discussion, then community converge and come a simple solutions. That's this vocabulary schema.org. That's for structured data. So there are 3 features for advantages for applying this vocabulary. It make simple things to be simple, so you can just use one namespace, a dozen of vocabulary, then make semantic meanings about your web metadata landing page or web page. And it can also permit complex things to be possible for advanced advanced webmasters. For example, they can mix vocabularies and namespace to do more complicated things. And ultimately, I use this vocabulary, and then it can make your metadata landing page understand not only by humans, but also by machines. And these things, these markups, this vocabulary exists about probably 10 years ago now. They have lots of, it has been used by lots of websites in a variety of sectors that include news, books, finance, e-commerce, and etc. And we can see many major search engines, web search engines like Google, index and do vertical search of those web pages with embedded structured data. So web search engines like Google, they also now apply the similar vocabulary and method to dataset search. So Google launched data search in September 2018, and early this year in January, and they are out of beta version. So officially they launched their product. So we will see, closely look our log to see if this product will be used more by researchers. So what this Google data search did, so there are two roles here. So for metadata publishers, you can map metadata in whatever standards to schema.org. Then encode that vocabularies in JSON ALD and insert that snippet in your metadata landing page. Then register that page in a sitemap, and that will be, the aggregator will take that sitemap, crawl your landing page, and process and extract structured data from your landing page, and do creative discovery from there. So this vocabulary, they are a set of types, and each type has a set of properties. They are arranged in hierarchy. And we need distinguishing the schema.org as it has a community behind that, and it's continually engage with the community and elicits requirement from community. And I see that number of type and property have been increasing through over the years. So here are a few the types that are very relevant to datasets. And for the dataset type, actually it is based on W3C DCAT. At the moment, it has 91 properties, and the properties listed on this page are those recommended by Google Dataset Search. So it's not the commercial tools like Google or Bing or Yahoo. They do something with structured data like from their tools. We research data infrastructure providers can also benefit from this common set of vocabulary via this web architect. For example, we could, for example, this vocabulary, if most of Catalogue use the markup in the landing page, that will enhance the interoperability across data catalogs. And this potentially a new method for aggregators to harvest or syndicate metadata from repositories apart from OAI PMH method. It also enables federated search across repositories of specific domain or related domains, depends on a research need. We can also create a spectrum of data APIs, data search APIs, from free text search, JSON API to Spark queries. So there are lots of possibilities there. So not only for commercial companies, but also for research data infrastructure providers. And here is example last year, we did a quick proof of concept project. So because there are already so many data repositories have this structured data embedded in their landing page, we just harvest from those repositories, crawl those structured data from these repositories. And this repository, I believe they are participants of Earthcube P418 project. That's a demonstration of web data discovery. So on the left side, we crawl structured data from those repositories. Then on the right side is a capture. We then process these structured data and rent them nicely in as you see here. So that's the context for this working group. We see so many communities already working on these vocabularies. So we bring this community together and provide a platform to exchange experience. We also would like to identify and bridge the gaps in existing schemas and provide guidelines for those communities whose needs are not addressed, and also provide guidelines if extension needed. So this group started in P13. We had a both session, then we had an inaugural group session at P14, and this is P15. We will report back the progress. Hopefully at P16, we will have draft recommendations or guideline. And P17 plenary is a deadline for us. We need to produce recommended output, ideally with adoption use cases. So we have 4 co-chairs and a number of people on technical advisory board that we hope represent a variety of communities and standards. We run monthly call on second Thursday at 8 p.m. GMT. If you want to participate this call, you can just sign up to the group. We also, other communication channel is like this. We participate in the plenary and also communicate through mailing group mailing list. Okay, that's enough from me. And next we will have 3 use cases. The first one would be from Jens. Jens Klomp is science leader from Cairo, Australia, and he will talking about IGSN group sample numbers. Over to you, Jens.
Thank you, Ming. Do you forward the slides, or should we switch over to my
Okay,
slides?
I switch over, whichever you prefer.
I'll use mine.
Okay.
Because I see there's some last minute changes that didn't come through.
Okay.
No worries. Let's see. Where's it? So do you see my slides now?
Yes.
Excellent. So I will briefly talk about one of the use cases for schema.org and from the context of the IGSN global sample number. And this presentation was put together by myself, Jens Klump, from the Commonwealth Scientific and Industrial Research Organization of Australia, Doug Fields from Ocean Leadership, and Jess Robertson from the Ministry of Business, Innovation and Employment in New Zealand. What is the IGSN? It's a global sample number, a persistent, globally unique web resolvable identifier for physical samples. And what we try to do with this thing is to provide an open, shared, and trusted, globally unique persistent identifier system for physical samples, specimens, artifacts, whatever you want to call them, in support of the advancement of knowledge. And what I think is important for this group is that it is an anchor of the knowledge graph into the physical reality. What's the challenge? So just estimating, each paper reporting on experimental results will refer to many specimens. The number of specimens is really large, and we know more or less that natural history collections alone hold approximately 1.5 billion objects. And many more specimens are ephemeral and are discarded after use or destroyed during the analysis. So it's fair to say that the total number of specimens in catalogs that we might want to refer to is absolutely huge. And these specimens can come from anywhere in the solar system and beyond, because we already do assign IGSNs to exosolar materials that came from satellite missions that collected interplanetary materials and collected some stuff that came from outside of the solar system. But it's not just the geosciences. There are other current users and projects that are preparing to use IGSN. Outside of the geoscience, that's the Australian Animal Health Laboratory. It's experimental farming in Australia, material science in Australia and the US, and archaeology in a couple of places. The question then is, what metadata elements are useful to support the FAIR principles for all of these communities and other future communities in such a system? And I think it's also fair to say that nobody wants to know everything about everything in the universe. So what IGSN needs to be able to do is to support community profiles so that communities can decide what they want to say about these objects. And this is where we use structured data on the web, because it leverages web architectures that provide scale that has been demonstrated on the internet as it exists. We can build on rich tooling for that already exists and a developer experience with JSON. And Ming already told us about what has already happened in collaboration with Google. This is also one of the outcomes of that. There are domain-specific tools under development. One of them is Gleaner, which is a program and a set of supporting Docker containers that allow for the harvesting, validation, and indexing of JSON LD data graphs published in web pages. Its goal is to allow users to generate graphs and other searchable index spaces based on the provided and exposed JSON LD. And there's also domain community authoring guidance coming, for instance, from ESET or bioschemas.org. So what this does is it creates a gateway to semantics and knowledge graphs, all the way from this physical object through web architectures to a tool that gives us new abilities. And what we can do now is we can extract things and validate workflows. And we can build services. We can build more than just catalogs. We can feed the harvested data into web feature services if you're in geographic space, CSV for the web for all sorts of other more general applications. We can transform it into other protocols like OER PMH, Z3950, if anybody remembers that one, Sparkle. We can use it for machine learning and extract training and prediction data sets automatically. And we can use it to validate services on metadata shapes. So to say, what expectations do we have towards the shape that metadata are presented. And the aim is to give the data to the users in the format that they want. And in IGSN, we use this approach to rethink our system architecture, where we then say, we use this power of these web architectures to improve and scale the way we harvest data. We publish metadata on landing pages, and we crawl and harvest these data and make it available for metadata aggregators, so that researchers then can search for information on samples in a much more rich way than they can do that at the moment. And just as a last note, I want to remind you that the linked data pattern lends itself to more than just data, but also to other entities. And by describing samples using JSON LD and Schema.org, we have a mechanism for making samples more fair. So implementing the FAIR principles provides a technical basis for open access to knowledge. These two things must come together. There's the programmatic promise of open access to knowledge, but we also need the technical basis that is provided through the FAIR principles. And that's all for now. I also want to thank quite a number of people who've contributed to these discussions. Here from the IGSN project, from EarthCube, other discussions, the IGSN project steering committee, ESIP, EarthCube, and the support from the Alfred P. Sloan Foundation. Thank you.
So I guess it's my turn next, Martin. I hope my screen sharing works. I will talk about Codemeta for the next few minutes. And this is about metadata for software source code. And that's sort of exactly the same story that you will hear regarding research data in this webinar. And of course, software source code is also part of RDA. We have one interest group and one working group, and one activity for another working group. And some people on the call might be involved in these various activities. So the starting point is the same. That's basically a slide similar to what Ning-Fang showed, just a little bit more about metadata standards for software, which is both general software package management, for example, but also software that is used for scholarly content. And it's a mess just like everywhere else. And Codemeta is a project which was funded by a National Science Foundation grant a few years ago, 2016 to 17, a 12-month eager grant to sort of address this problem. And this project has produced several important outputs. The first one was a crosswalk tables between all these different metadata standards. So how do you convert NPM package management metadata to doubling core? Give a crazy example. Then sort of all the commonalities were extracted into a new schema, the Codemeta schema, which is technically based on JSON LD that Jens talked a little bit about. And I think most importantly, this has become the community standard, at least for scientific software. So everybody who is working on metadata about software seems to be preferring Codemeta, and the discussion, whether it's in RDA, in the FOSS 11 working group regarding software. There's basically no discussion. This is sort of a community standard for these people who care about this stuff, which doesn't mean that the average researcher necessarily knows about Codemeta. So adoption is still a challenge. What's the relationship to schema.org? That's also already my last slide. As I said, Codemeta is already JSON LD, and the Codemeta actually reuses schema.org to a large extent. The majority of terms are taken from schema.org, and that was a process that didn't start from the beginning. There are 10 terms not defined in schema.org, and we, meaning the Codemeta task force from the FOSS 11 Software Citation Implementation Working Group, sorry for the long word, we decided last year we should try to describe Codemeta metadata completely in schema.org. And the arguments are probably very similar to the drivers for this research schemas working group. Specifically, we want to be Codemeta part of a bigger community to secure long-term development. Codemeta was a project and there's a lot of community effort, but that's sort of, that doesn't secure that this is still around and updated in 10 years. It will broaden the community because, for example, many more people look at schema.org metadata properties than on something specific like Codemeta. And of course, we hope to reuse tools and services that are built for schema.org in general, and that includes, of course, the work of participants in this working group. So we decided that this is a useful path. There was not much discussion. We, of course, also included the two people who started Codemeta, so Carl and Matt, and they were happy with this. It was just that the project had a sort of time and the resources, so otherwise they might have done this themselves. So we started task force and basically went through all the 10 remaining terms and come up with how could this look in schema.org. Luckily, 2 of them have since been added to schema.org. For example, funding is much better now. And we are sort of on a good path. We have suggestions how things could be called and described. And we are sort of have started to discuss this in the Codemeta GitHub repository for feedback, and hopefully in the next few months have completed this. We'll go to the schema.org community, which, as some people on this call know, schema.org changes to metadata mainly works through their GitHub issues in their main repository. And we don't know how easy or difficult it will be to adopt, but because it's a short list and we don't really ask for crazy things, and there's a community behind it, we have good hopes that this will be added to schema.org vocabulary so that you can describe software using Codemeta with schema.org, hopefully by the end of the year or something. Hard to say, but the direction is clear, and I'm hopeful that we will get there. And that's my last slide, so thank you very much for listening.
Thank you, Martin. Next one is Leila. Leila, do you want to control slides from your end, or? Okay. Leila, you are on mute.
Yeah.
Yeah.
Am I on mute now? Yes?
No, we can hear you now.
Oh, okay. Yes. So you can hear me.
Yeah.
Okay, perfect. So let's going to move here. And you can see the slides corresponding to the presentation.
Yes.
Okay, perfect. Thank you very much. So my name is Leila Garcia. I work with the Information Center for Life Sciences in Germany. And today I'm going to present you a work that we have been working on with mainly Elixir people, but also there have been some people involved from Goblet initiative. And it is about metadata for FAIR training materials. I will start by sharing a little bit of how it all started. So about 2 years ago now, there was series of presentations about how the training platform in Elixir Europe was trying to introduce FAIR elements to the training materials. Then that same year, 2018, we had the first Elixir Europe Biohackathon. And I, together with a group of different people, put together a subject on how to assess fairness on training materials. So we started this work 2 years ago, and we realized that opposite as it happens in other domains, there is no much metadata on training materials. Our first approach was Bioschemas. Bioschemas is an initiative to add life sciences types to schema.org and to provide profiles on top of the schema.org types, because the schema.org types are easily coming with 100 properties, and that is difficult to handle. So Bioschemas offers some profiles or guidelines about what are the most common properties that can be used within the life sciences context. There is something in schema.org about training materials, but it is not easy to use. You need to have like a lot of imagination to understand their descriptions and to adjust their descriptions to your training materials. So we realized that we didn't have enough vocabularies. We realized that it was not totally clear what FAIR meant in terms of training materials. So we start working on what are those elements in training materials that could contribute to the fairness for them. And we became with these 10 recommendations that should be soon published as a 10 simple rules paper. It all starts by sharing. And this is true not only for training materials, but for any other research object. If you don't share your stuff and you don't think about sharing it from the very beginning, later it could be difficult because maybe you didn't take into account the sharing and what it is needed when you are providing data, training material, software for someone else other than yourself or your institution. Then we need to describe the training materials properly. Yes, I know properly doesn't say much, but in the description, what we mean here is you need to say what your training materials are about, and you need to do it with metadata. If you have it all in full text, it will be difficult for others to process this programmatically. So it is very important to add metadata. And that is something that in training materials, it is done by initiatives like Carpentries and like Galaxy that are really big communities, but for the casual trainer, that is not true. The other thing is give a unique identity. So we are talking here about persistent global unique identifiers and doing a registration online. We know that Google is capable to find anything, but Google is not specialized on anything either. So we think that on top of just allowing people to find your training materials via Google or any other search engine, Yahoo, Bing, etc., there should be used also specialized registries, in this case for training materials. There is one, for instance, in life sciences that it is provided by Elixir, that it is the TESS portal, specialized in training materials and events on life sciences. Then it is very important that you define the access rules to your materials. It could be that it is behind a membership, and that is fine. Fair is not the same as open, and we need to remember that. And there's certain things about copyrights that we need to respect as well. We would like everything to be open, but there are some aspects that need to be tackled there. So we should be respectful toward that. But the important thing is that you let everybody to know how to access your training materials. Are they open? Do you need a membership? Do you need to pay a fee? Whatever the way is, you need to make it clear. You need to use an interoperable format. This, when it becomes to training materials, is a little bit tricky. The most common way to share training materials is via PDFs. And editing PDFs is not easy. So we are making people aware about other formats. PDF is okay, we are not against that or anything like that. But if you're sharing the PDF and you want people to easily be able to build on top of your training materials, maybe also provide a source for this. For instance, the PPT, or make the source available via Google Slides or other means. Or use something like Markdown and host it in GitHub. That is another possibility. That is, for instance, what carpentry's materials do. The important thing is that if you really want to allow people to build on top of your training materials, you need to make it easier for them. Make reusable your materials for trainers. We cover the interoperable format, but making reusable for trainers also means that you include in your training materials elements that other trainers can take into account to reuse your training material. For instance, what are the skills that are required before starting with these training materials? What is the audience that you are targeting there? How you should prepare and how this training material could be embedded in other training materials. And this goes in hand with the make usable your training materials for trainees. If you just share your training material and don't let people know that this training material is about genomic sequencing, and you should know this and that before coming here, otherwise you could struggle or you could get confused with the material, or the learning outcomes are this and that, for you to be to have enough information to decide, oh, this is the training material that I'm looking for, this is the one that I will look at. Allow for contribution is our 9th rule. Make sure that you let people know if they find a typo, if they have a new example that would work great with your training materials, how they can contribute to it, and how they will be acknowledged for it. We all know that with very collaborative tools such as GitHub for software, for instance, you can get contributions from everywhere. And you can have, let's say, 100 contributions, but you need to make sure, for instance, if a publication is coming out of it, will any contributor will be considered a co-author, or only those that have been heavily involved in the project and so on? It's the same thing with training materials. And keep your training materials up to date. That is very key. If there is nothing to update, because, well, it could happen. It is kind of difficult nowadays when things move really, really fast. But the important thing here is that you need to use a timestamp on your training material so people know where it was the last update that it was done. We realized when we were doing all this work that we also need to provide training materials about FAIR, what FAIR means, how researchers could approach to FAIR, what to look at it, and how make things fair. And you need some skills for that, and there is some terminology that it is around that. So the same group that has been working on this 10 recommendations about fair training materials, have also worked on a set of terms for fair skills. I added the link to this slide in case you are interested in this subject. And that is what I wanted to share with you today. I will have a look in a moment to the chat in case there are some questions. And thank you very much for listening.
Thank you, Leila. That's end of 3 presentations of user cases. As you can see, some are really aligned up with Schema.org, some hasn't. That will be for this group to consider when we identify gaps and etc. Leila, there is a question for you. Probably you can type your answer in the chat. I will continue the next presentation. How's that?
Will do so. Thank you.
Okay. Okay. Fast track. So next is a presentation of this mapping of metadata schema to Schema.org. The presenter is Karen Pang, but it's 2M or 3M her time. So I will talk over her slides. Hopefully I can do justice to that. So when we started this working group, we conducted a survey to gather information on existing work involving schema to describe research data and the related resource. We hope this survey can help us and the repositories to understand the current practice, identify commonalities, gaps, and barrier for our for identify scope for this work. And so in that survey, there is a question about if you have do any mappings from your metadata schema to Schema.org or other schemas, not just Schema.org. So there are 20 organizations participated in the survey, and 13 of them provide the link to their crosswork to Schema.org. So what we did is we collect all those mappings into one this spreadsheet. It's much we learned from Codemeta, what the Codemeta did, their crosswalk table. So we have properties from Schema.org. Properties recommended by Google Data Search, and the properties recommended by Codemeta, and the properties from DCAT. We find those common properties and as a base, and map other schemas to this common set. So what Karen and her students took this further, they implemented these visualization tools to for number of features. These visualization tools have 3 features. The first is called the schema field table. So you can select a schema from this pull down list and look at how the property from that schema, for example, from DCAT, how that map to Schema.org. So if you have a schema and you want to map to schema.org, you can check this table if someone else has already done it. The second feature is schema search table. So what that does is, if you can put in any property or terms in the search box, then it will find the match of those schemas with that term. So the term could occur in the sourcing schema, for example, IOSC or ISO 19115, or as a targeted schema.org. So you can see that property exists in which schema and how that mapping to schema.org. The third feature is called a Sankey diagram, and it's more like a visualization tool to the previous ones. So you can put in a schema.org property in the box, in the search box, then you will see what kind of terms in the middle of this diagram, and from which source on the right of this diagram are mapped to that property. So so of course there sometimes because the noise of the data, it can affect the display of that visual tools. For example, this schema RIFCS, it mapped many properties to one. If it's many to one, then that will cause issue. So if we want to develop these visualization tools further, we need to learn how to deal with that. And this is not included in that tool, but idea that we could use a diagram like this to visualize the number of times the schema.org properties that were not mapped to a corresponding metadata term. So, for example, the schema.term subject of within the corresponding metadata term within the class within class subject of that was not mapped from any of those schemas. So we have 13 mappings together, so none of those were mapped to this property. And if you down the right hand, it's not shown, the property name is not shown from this diagram. You can see that term is mapped from many schemas. And here, this image would show the number of terms in metadata standard that did not have a schema.org property. You can see the DDI that have a big box. There are less schema.org terms across worked in that schema compared to the schemas at the right hand. So these visualizing tools, with as I already talked through, we have use cases for each features. So the question for us to discuss is this tool useful? Does it help for us to identify planned outputs? That means identify gaps and commonalities and develop further. And are there any other visualization tools like this that will be more helpful for this purpose? Okay, so that's progress we made so far about the crosswalk and the metadata mapping. So what's time now? So it's almost close to 9 o'clock. We have 30 minutes left. We would like to have a breakout sessions to discuss questions as listed on this screen. So basically, first 3 questions are asking if you want to implement the markup, what you want to know, and if already implemented, what experience you can share with others. And the 4th question is about crosswalk, and the 5th question is about tuning. So we have 36 people on the call. We can break up in 6 rooms. I hope the co-host on this room will be in each room to lead the discussion. Okay, so let me stop sharing. Please, while you are discussing, please add your notes to each question in these collaborative notes. So now I send you to breakout rooms. Hi, this is room 5. Let me find the collaborative notes.
I think we're in room 2.
Oh, room 2. Oh, right. Yes. Sorry, it's room 2, 5 members. Thank you. the collaborative notes.
So I just put the names down in under the breakout room too, but other than that, I'm not sure what to do next.
So, okay, I go to the room 2, the notes Zoom. Go there. Yes, thank you. So we can go from the first question. If your repository catalog is about to implement markup, please name 3 things you would like to know. So we have 5 people, including me, and so have you or have not implemented the markup?
Can you explain what you mean by markup?
So if you have a landing page, you have already insert the vocabularies in JSON LD, that's called markup, into your metadata landing page.
Okay.
So basically, you have published the structured data to your.
At this point on my side, we we published through DataSite, but I didn't put any JSON LD on the landing pages.
So sorry, can you type in your name, initial name, then?
Yes. So where I don't see where I should. I don't see where.
So on the page 6. So here is collaborative notes. I put in chat. Have you got the collaborative notes?
No.
Yeah, I put in chat now.
Oh yes. Okay.
Okay. So Baptiste.
Yes.
I hope I got your name right.
Yeah, I know it's difficult from.
Thank you. If you put your names.
Yes. So I'm
here,
from Paris Observatory.
Yeah. Say so what you just said is we
I can type in if you want.
Okay. So you send metadata to you rely on DataSite to.
Yes. Well, this is I've been registering 8 data sets for the last 2 weeks, so it's really handmade and very early. So I'm learning.
That's a start. That's a start.
Yes.
So you can type in, whatever. Yeah. So other people can type as well. You don't have to wait other people to finish. So then So that's probably a good question. Do you have a plan? You are doing that yourself?
Basically, I just learn what it is now. So yes, probably I will put that in the plan.
Okay.
Yeah.
So if you want to learn, say, what kind of information in which format would be useful for you?
Well, the thing is that I'm already putting quite a lot of information in the DataSite metadata. So I guess I would map those. But I saw that on the if I go on the search DataSite interface, on their intermediate landing page for a given data set, there is already some JSON LD metadata that is there. So I'm planning to inspire from that because this is the metadata I already have.
Good.
But yeah, I'm learning, so I don't know exactly yet.
Good. And so how to represent subject in data side with the schema for the. So Brian, so you mean the subject property?
Yeah.
Okay.
So I'm trying to think about fair data and thinking about subject terms, but then also representing the scheme URI for that subject
Okay.
group of subjects.
Yeah.
And honestly, I'm not sure, just really have never thought about looking at schema.org as kind of the baseline to go for.
Okay.
So for instance, if I have a chemical, if it's a chemical substance and I use INCHI to represent that chemical substance, or if I use PubChem ID to represent that chemical substance, how does that get crosswalked into something that schema.org can use? Does that make sense?
Yes, that makes sense to me.
I don't know how to write it out in a way that makes sense, but that's kind of where I'm at.
Okay.
I'll give it a shot.
Okay, thank you. So, your repository, I assume, haven't implemented any markups yet.
Yeah, one thing that I ask here is because, well, so I'm in an astronomical observatory, so we already have a lot of interfaces on using the astronomy virtual observatory.
Mm-hmm.
So a lot of metadata is already there for that.
Yeah.
And we have specific interfaces using those protocols. So I don't know yet how to, how I would advertise those and how do I map the metadata. So probably it's not done yet.
Mm-hmm. Okay.
So this is something that should be looked at because there is a lot, the ecosystem of the Astronomy Virtual Observatory is quite rich already.
Mm-hmm. So, so from our collection now, we haven't included, we don't have one registered from,
okay.
Yeah, from Astronomy Virtual Observatory. But I can ask my colleagues here, they from Australia, astronomy. And
I know that the people in Australia, the people working in radio astronomy,
yeah,
they have already some interfaces, and there is a data center with an astronomy data center with IVOA interfaces and metadata. So there is some knowledge in Australia,
yeah,
mostly in the radio astronomy and SK world.
Okay, so so that's the first question. I assume the second or third question may not apply to us here. The second or third assume you have already implemented. So yeah. Then the fourth question is any suggestion about collecting, collating, and analyzing crosswalk? So at the moment, you can see we collected 13 of them. Do you have any suggestion about this activity, how we can improve from there? So basically,
So I'm not very familiar with this crosswalk concept. So is it the mapping between the dictionaries, the various metadata dictionaries?
Yeah. So,
Okay.
for example, I insert link here. That's the crosswalk we collect. If you go to that link, then you will see. So there are about 12 or 13 of schemas. For example, from IRSC, from ISO 19115, and DCAT, etc. They are mapped to schema.org. So activities like that.
Okay, yeah, this is something that we could do in the Astronomy Virtual Observatory, indeed. And there are some. Maybe I can list because I'm a bit interdisciplinary. I'm doing astrophysics. I'm doing planetary science. I'm doing solar physics. So all those communities have different ecosystems of metadata and protocols. So maybe I could list the various metadata schema and dictionaries that the people are using. So and then yeah, I can try to find people to do the mapping somewhere.
Yeah. Yeah.
Maybe I'll do
so
it,
we can find a way of crowdsourcing something like that.
Yeah, because I can't do it myself. Everything.
But sometimes
but I have some ideas. Yes.
Yeah, but sometimes you need to know the discipline. You know, one domain in one discipline may not the same in another discipline.
No, but there is a working group in the IVOA, the Astronomy Virtual Observatory, on that could work on this, I guess. So I will put a message to them. Observatory. So in space physics, so it's space measurements of physics. There is space, that is the so there is a schema that is that we can map also. I guess there is also the NASA Planetary Data System. So those are things that are, the last two are things, NASA Planetary Data System, PDS. These are the space, so it's archive, search and extract. Space and PDS are archive metadata, archive system metadata. So there is a lot of resources using those metadata.
It's good.
So this is just the main page for those, but then yeah, we can maybe. Well, I will try to coordinate that with those people if they are interested. At least I will show them and see if they're interested.
And the last question, any suggestion about the collecting, sharing, and collaborating on toolings? For example, the visualization is one of two, and like a Codemeta, they produce a tool called Codemeta JSON LD generator. So they took the metadata in format and generate a JSON file for that. For example, let me see toolings. What is toolings? Yeah. Yeah, please type your initials before you are typing, and so
Sorry.
we can follow up who did what there. If we have a question, we can contact you.
Yeah.
Zachary, do you have anything want to say?
No, not really. But I posted the question that I would ask.
Zachary, what are you referring to? What scientific or domain when you say variable measured?
Well, it doesn't have to be a specific domain, but that's a property in data set. And it's one that I'm interested in. And I was just curious to know if others in any other community are using that property.
And what's the definition of that property?
Well, I don't have my web browser open in front of me. I'm connecting on a phone app.
But basically, it's the, yeah.
Well, so it can be one of the allowed types is property value, and a property value can have a name, a value, a unit text, a unit code, a property ID, and I think it could be a very powerful component of schema.org to represent, specifically in my domain, scalar material properties. And I wonder if other communities are leveraging it at this time.
So is it like you can advertise here that you measure temperature in Kelvin, for instance, or you give also the number?
Yeah, you could use it for that.
Okay.
As far as I can
well,
tell.
In astronomy, that exists, of course. We have this kind of thing. In the various examples that I listed in the section 4, yes, there are some. So the mapping could be done. And I think it's useful. Yes, if you look for data, you probably look for a given you may look for a parameter, a specific parameter like a temperature or a density or whatever, depending on the subject. But yes, I think that's useful.
So yeah, I wasn't asking if the mapping could be done. I was just asking if any community is leveraging it. Yeah.
As I said just above, I'm new to this. I would use it. If it was if I knew, well, if I will look into that because I think it's an important discovery term. If you yeah.
Okay. So it's 9:20. We have to wrap up this discussion. Please, if you have anything to add, continue type. So I now close all rooms and then we back to the main rooms. Oh, sorry, Martin, I didn't see your message. I was in small room.
I just typed it in.
Oh, you just type in. Oh, we all back to main room now.
So is this a 90-minute RDA session length, or is it a little bit more because it's virtual and different anyway? As you said, it's not 3 hours, but I'm not sure how much time we have left.
Oh, it's 1.5 hours, so we supposed to finish in 8 minutes. So are we all here? Seems not, but all breakout rooms closed. Have we lost people?
Looks like we lost
I'm
3
sure a few
people.
people dropped out.
Okay, because
Yeah,
Leila, I don't even see you.
Oh, but I am here.
Okay.
Well, oh, yeah.
Okay. So anyone want to report back? Breakout room 1. Yes? You are on mute.
Yeah, I'm unmuted now. So we were only 2 people in breakout room 1.
Okay.
So we talked about what Manuela does, looking at metadata for the data repository. And since she's new to this working group, we've talked about the question of how to look at the general versus specific and how to then arrive at a compromise. And since that the hosting arrangements for that repository give them certain limits to what they can do, the question is then how would they get the best value choosing the right metadata that also then match with schema.org.
Okay, thank you. And I'm from the room 2, and we have 5 people, including myself. So so all new to this structured data markup. So one rely on data science, Martin, to publish the structured data. So you can see, yeah. So basically, we want to see more crossworks from other disciplines and tools from respective domains as well. Room 3, only 2 people, Martin and others.
Yeah, so Dorothea and I had a German language RDA session because we're both in Germany.
Oh.
And we went through the 5 suggested questions, and Dorothea, they are using Dataverse as a platform and for engineering. And Dataverse has a nice schema.org implementation, so there weren't many lessons learned or pain points because it's mostly working. It's just that there's a little gap that not everything in schema.org is also supported by Dataverse, but that's sort of, I guess, it was work in progress. On the data side, we have spent a lot of time with mapping data set with schema.org. That overall was a nice learning experience because it's similar enough that there are only sometimes questions how to do that. The biggest time we actually spent on discussing something that is important for this group, but we didn't talk much about it. Schema.org metadata is not metadata for everything, but it's still general metadata. The boundary to discipline or sub-discipline specific metadata that nobody else cares about, how you integrate this, sort of a clear path for that. So in Dorothea's case, it was engineering, but I think this comes up a lot. What I talked about Codemeta earlier, I think software is generic enough and the Codemeta meta is generic enough. It's not an issue there, but for many things, maybe also IGSN, and that would be nice if this group can work out a clear path how you do that, because the solution is probably not to put every metadata property you need in your discipline into schema.org, because it will never get in there if you have a small community, for example.
Yeah, that's a good point. We should be clear what's the purpose we want to do this markup in schema.org.
And finally, tooling and services around this that are specific to our community. That's super important for both of us. Not just relying on, for example, Google to validate your schema.org, etc.
Yeah, thank you. Room 4.
Yes, so I was in that room. I kind of lost track of time, so we were kind of code out of time for the discussion. But I have gone through the notes, so I can summarize. We were 5 people, 3 of them totally new to the subject. So they were looking for information that would help them start on their own organization with this sort of markup. So something that I would get out of it is that people kind of like to see examples of what others have done, because maybe that will help them do their own thing. That would be related to the first question. And then related to the second and third question, having clear requirements is very important. Remembering that although most pages are asynchronous now and there are single page applications, still crawlers might have hard times with that. And from the suggestions, don't make a new standard. This was one of the clear messages here. And for the crosswalks, there were some suggestions in there and the links are available there. And there is one question for Martin, I would say, Martin, about how to combine DataCite and JSON-LD. Maybe you can say something about that very, very quickly. We have 1 minute.
Very, very quickly, we have a mapping schema.org to DataCite, both directions. So when you register DOI, you can register with schema.org. If you want to get DataCite metadata in schema.org, you can do this in content negotiation.
Good, so DataCite indeed has a way to do so. That was everything from our group. Did we have, yes, we had a breakout room 5.
Yeah. Oh, yeah.
Hey, Meg.
Yeah. Hi, Adam.
Hey, folks. Yeah, I can go through our discussion here fairly quickly. On the point number 1 about new implementations, 3 things that you'd like to know. Our group discussed just how great it would be to have example JSON-LD to sort of reference, or at least help you wrap your head around how your own content aligns. And then an understanding of the property types and their expected values, which isn't something that is necessarily obvious from examples, since there's multiple ways to represent certain properties. For folks that had already implemented the markup, some things that would be good to know is that, you know, the turnaround time for Google to sort of harvest that and ingest it, that there's not really an immediate check on whether your markup is you know, not valid, but what it'll look like in, say, like Google dataset search. And then just some ideas around like issues with crawling sitemaps and how that is an important factor on what gets harvested and shows up in the Google dataset search. And then also just some, yeah, go ahead.
You got toothpaste on your face.
Oh, yeah. Okay, maybe that was not for us. Then the last point was just how the Google structured data testing tool sometimes throws errors when there are more warnings, and that has to do with Google's own interpretations of schema.org and what they think are best practices there. And then we probably spent way too much time on those and didn't get to the other points, but I just wanted to highlight that someone in the group also just typed in the breakout notes that on point number 5 on suggestions for collecting, sharing, and collaborating on tooling, that it would be great to provide example codes for different repository platforms. So what does schema.org look like for DSpace or ePrints or other platforms like that?
Great, thank you. And move to room 6.
Yeah, sure. I'll speak up for room 6 here. So, and just quickly, as we're tight on time, I see, but we went off the rails pretty quickly, and really kind of got into a discussion of some of the issues of schema.org as a lightweight semantics, and how well can we describe more domain-specific items when connecting to that, and so therefore then the leveraging of extensions, connecting you know, a JSON LD packet that scopes both schema.org and maybe a domain-specific ontology, and how to bridge those two, and a little discussion about some of the stuff that was going on in there. We talked a little bit about the role of persistent identifiers as keys in a graph like this, how to do search interfaces into these type of things, and then also it's somewhat related to the first topic. Then the idea of metadata profiles for communities, and how those might be implemented and validated and checked, and elements like that. So it was a fun discussion. Jess, Pascal, and Milan were in there, and so we had we enjoyed our time, even if we didn't address the questions very well. And so if anyone else from the group wants to chime in, they can, but that'll conclude my report.
Thank you. Since we have quite a few people new to this group and to this work, and Leila often asks people if they are interested in webinar, something like that, to show how to discuss this first.
We have at the end of our collaborative notes a table asking for how people would like to participate regarding tooling guidelines, etc. I just added a new column there for you to express your interest on a webinar, whether as a presenter or as an attendee. So we can see if we can organize this.
That's great. Please indicate that you are interested in the collaborative notes. So if enough interest, we will organize a webinar as such. So sorry, we 5 past, and basically we went through all agenda a little bit over time. So there are lots of notes and from breakout rooms. So we will process and analyze them and incorporate in our future work. And last, Stephanie asked me to insert these slides because we found there are quite a few people. They are not a member of RDA but join the virtual plenary. That's a good thing. But if you want to notified about future activities, you can be a member of RDA. Just follow the link on the slides. You can register. It's free. After you be a RDA member, you can join any group you are interested and contribute to that group. Okay, I'm sorry about overtime, and last but not least, thank you all, and especially our speakers. Thank you for your participation. Please stay safe, keep well, and if you join the group, you will get notification for monthly call. Okay, thank you. Goodbye, everyone.
Thank you, everybody.
Bye. Thank you.
Bye, everyone.
Yeah, it's a little bit over time. Stop recording.